Today we're going to talk about solving equations and the basics that go into how we solve an equation. So let's think. What is the main goal when we are being tasked with solving an equation? Our number one goal is always, no matter how long the equation is to isolate the variable, meaning get the variable or the letter by itself. You want nothing else with that variable, not even a negative sign, okay? So our main goal every single step of the way is to isolate the variable and get it completely alone. Well, what allows me to do this? What allows me to do this is inverse operations. I'm allowed to bring something, I'm allowed to manipulate my equation and swap things from one side to the other by using the inverse. But we always have to keep our equation balanced. It's kind of like that balance scale in science. If you do something to one side, you have to do it to the other so it stays equal. So the inverse operation of addition is subtraction. While on the other, the inverse of subtraction is addition. Multiplication and division. And something that might be new for some of you is the inverse of squaring a number, meaning timesing it by itself. That inverse is taking the square root. That's going to come into play a lot when we're solving quadratics or we're solving Pythagorean theorem and dealing with perfect squares or not perfect squares, okay? So let's take a look how I would do this. So here is our equation. I have negative 2x plus 4 equals 8. Okay? So remember, our goal, and it's always going to be our goal, is to get x by itself. So I want this variable x to be completely alone. Nothing else with it. Okay? So the first step, get the term that has the variable alone. So I'm going to focus on getting negative 2x by itself. Well, how do I do that? I need to move the 4 to the other side. What allows me to move the 4 over? Well, since it's being added, the inverse of addition is subtraction. So I like to draw this imaginary line straight down my equal sign. You could call it a river. To get to the other side of the river, you have to do the same thing, and it's the inverse. So to get rid of a positive 4, I am going to subtract 4. Well, if I subtract 4 on my left, I must subtract 4 also on my right. This is going to help keep that equation balanced. So it leaves me with negative 2x equals 4, okay? So I'm not done yet, and I know I'm not done because I have not gotten my x by itself. So how do I get the x by itself? I'm still focusing on that goal. I haven't obtained my goal, okay? So my next step is to get x by itself. Well, how do I get x by itself? I need to move the negative 2 to the other side. What allows me to move it to the other side? Well, if I take a look here, okay, I'm trying to move this negative 2. And I say negative 2 because I also want the negative to go with it. I don't want to leave a negative with the x. So to get rid of this, I'm going to do the inverse, which since negative 2 is being multiplied by x, the opposite of multiplication is division. And I know it's being multiplied because of what we have gone through basics is a number right next to a variable with no sign means multiplication. So since I'm multiplying here, I would divide negative 2 by negative 2. What's going to happen is that will cancel each other out to leave me with just 1x, which is what I wanted. If I divide the left side by negative 2, I have to divide the right side by negative 2. Therefore, I have x equals, -2. Okay? So now it's your turn. Okay? Take a moment, pause the video, and try this one on your own. Let's see how you did. So I'm going to draw my imaginary line again. Okay? Remember, I'm trying to get P by itself. The only way that I'm going to get P by itself is to start by bringing over what's not touching it. So I'm going to start by bringing over -7. Well, in order to undo subtraction, I would add 7 here. If I add it on the left side, I have to add it on the right side so that my equation stays balanced. What ends up happening is I end up with just 5p on the left and 35 on the right. Okay? So now my goal is going to be to get p by itself. Well, how do I get p by itself? 5 is being multiplied by p. So to undo multiplication, I'm going to divide both sides by 5. So when I divide both sides by 5, that leaves me with p equals 7. Okay, how'd you do? So this next one might be a little confusing for some because we're dealing with a fraction. A fraction is still a number, guys. It doesn't change. It doesn't change what you're doing in anything. So I'm going to go through this one without putting my imaginary river because you're going to see it sometimes without that line drawn. You got to think of your equal sign as that river. So first, I'm going to undo and I'm going to bring 6 over. I'm going to add 6 to both sides. What this does for me, it cancels this out and just leaves 3/4 m. Well, now I got to stop and think. I am multiplying 3/4 by m. How would I clear multiplying by a fraction? Well, the opposite of multiplication we talked about is division. When I divide by a fraction, dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to multiply both sides by 4/3. And I do both sides because I want to keep my equation balanced. This cancels this side out and it just leaves me with an m. Over here, nothing simplifies, so I get 40/3. Ladies and gentlemen, you're going to get fractions and there's nothing wrong with getting a fraction. It is okay to leave the fraction improper. It actually saves you making a larger mistake. Okay? So that is a 2-step equation. That's pretty basic. So let's take a look here. So what now? What in the world do I do now? Well, I'm going to offer for you right now a series of about 6 steps. These 6 steps can be applied to every single equation moving forward. You'll use all of them sometimes and sometimes you won't. You can even use them on the examples we just did in a 2-step. Okay? So here's what step 1 is. Always, in solving an equation, distribute. Distribute. If you see parentheses, you need to get rid of them. So what does this look like? Well, I'm going to distribute the 2 to the 6 because it's right next to the parentheses. That is my distributive property. So 2 times 6 is 12. Since there was a u there, it is 12u. And then I'm going to multiply 2 times -1. And you've got to be careful. We have to remember, as we've talked about all year, a negative and a subtraction sign are interchangeable. They are the same thing. So 2 times -1 gives me -2. I'm then going to bring down my -2u because there was nothing I could do to that. And my 8u plus 8. Now I have distributed. I have cleared my parentheses. I'm done with step 1. Step 2. Step 2 is to combine like terms on each side separately. And when you combine like terms, you're combining like terms through addition. So what is a like term? A like term is something that has the same variable raised to the same power. In this particular equation, I only have these 2 like terms on the left. Once I circle them and I group them together, I get 10u. I'm going to bring down my negative 2, and then I'm going to bring down my 8u plus 8. If you look at the left side, there's no other like terms. If you look at the right side, there's no like terms there. Yes, 8u and 10u are like terms, but remember, right now, they are on opposite sides of that river. I cannot bring one to the other side yet. So I have now finished step 2. My step 3 is to bring variables all to one side. In order to bring the variable term over, you'll always be doing this by addition or subtraction. Always. I prefer to bring my variables to my left side. And I'm going to caution you here, always do step 3 before you attempt step 4. And there's a reason why. You always want to group variables together first, because it might save you other steps in the long run. So let's look what this looks like. I have an 8u here and a 10u here. Like I said, I like to bring my variables from the right to the left. So to undo a positive, it is a positive because there's no sign there. I'm going to subtract it. If I subtract it on the right, I must subtract it on the left. That's going to leave me with 2u minus 2 equals 8. This 8u and this 8u canceled each other out. They are now gone. The only thing left on this side is an 8. If you have 5 apples and you give 5 apples away, there's nothing there to write. So we don't write anything. We don't write 0u. Okay? So I'm looking at this equation now. Oh, it kind of looks familiar from what I just did. That leads us to step 4. We bring our constants to the opposite side of the variable. A constant is just a number. It's something that's not going to change. So right now in my equation, my constants are negative 2 and 8. My step 4 says bring the constants to the opposite side of the variable, which means I'm going to take this negative 2 and I'm going to bring it over to this side. So to undo subtraction, I would do addition. So I'd add 2 here. If I add 2 on the left, I also have to add 2 on the right. Okay, that's going to leave me with 2u equals 10. If you've done this right, what's going to happen is you have one step. Your step 5 is always going to be the same method. You're going to get this variable alone. You're either going to get it alone by multiplying or dividing. It's going to depend what's there. Right now, I have multiplication. So to bring this 2 over, I'm going to have to divide both sides by 2. Because to bring something over, I do its inverse. Therefore, I'm left with u equals 5. Now, I said there were 6 steps. My 6th step is to check. What does it mean to check? Okay, so what does it mean to check? Well, we just solved on our last slide and we said that u equaled 5. So I've got my original equation. The best bet, anywhere you see a u, replace it with what you said it equaled. We said it equaled 5. So I'm going to replace u with 5. I'm then going to simplify. I'm going to do order of operations. So first I do 6 times 5, which is 30. and 2 times 5, which is 10, and 8 times 5. Order of operations tells me to go inside my parentheses to get 29. I then am going to multiply to get 58. I'm then going to, on the left side, subtract, and on the right side, add. 48 does in fact equal 48. If both sides of your equation work down to the same number, then your solution is correct. If when you do it, you have unbalanced sides, there was a mistake in your solving, you need to go back and check. Okay? So, take a moment to pause now and try this one on your own. Let's see how you did. So, first step, distributive property. When I go through and I look at both sides, there's no parentheses, meaning there's nothing to distribute. Therefore, step 1 is done. I didn't have to do it. And sometimes that's the case. There will not be a distributive property. So my next step is to combine like terms on each side. Okay? So if I take a look, I'm going to have a negative 47x and a negative 5x. If I combine those, I get negative 52x. There was nothing to simplify on my left side, therefore step 2 is done. So now, step 3, bring your variables to one side. And I do that by adding or subtracting. And the reason I say or is because in this case, my variable this time is a negative. So to bring a negative over, remember, a negative is the same as subtraction. So I'm going to add 52x. If I add it on the right, I must add it on the left. Okay, so that's going to leave me with negative 5x minus 22 equals 43. Notice I haven't done anything with the 22 or the 43. They just kind of hang out there until I'm done. So I brought my variables together. I only see one variable. So that brings me to step 4, where I'm bringing my constants to the opposite side of where the variable's at. So remember we said a constant is just a number that's by itself. So in this example, I'm going to bring the negative 22 over to the same side as the positive 43. So I said negative 22 because it's being subtracted. So the opposite of subtraction is addition. So I'm going to add 22 to the left. So I also add 22 to the right. This helps me keep my equation balanced and both sides equal. Therefore, I get negative 5x equals 65. I've officially finished step 4. My 5th step is to now get the variable by itself. If you've done step 1 through 4 in the correct order, you're going to multiply or divide. I'm going to divide now because my problem starts with multiplication. So since I'm multiplying negative 5 times x, to undo multiplication, I'm going to divide. And I'm going to do that to both sides. That leaves me with x equals negative 13. I've solved, I've gotten the variable by itself. Be sure that you do plug negative 13 back in and check. Had you done that, you would have seen that it is in fact correct. So, now is a good time to pause the video on your own and see if you can get this one answered without any help. So pause now. Let's see how you did. Remember, my step 1 is always going to be the same. It doesn't matter what problem you have, and that's to distribute. Well, if you take a look at this problem, I've got parentheses, and I actually have parentheses on both sides. So, first I'm going to distribute the 9 to the 5x and get 45x. I then am going to distribute that 9 to the 11 and get 99. It's a positive 99 because both my 9 and my 11 were positive. I bring down my 21 and then I move to my right side. Here I'm going to distribute my negative 12. Negative 12 times x gives me negative 12x. The negative 12 times a positive 9, okay, notice this is a negative, this is a positive, gives me negative 108. I've distributed. If I look at this line, there's no more parentheses. I'm done with step 1. So step 2 was to combine like terms on each side. If I go through and I look, I've got a 99 and a 21. That's going to leave me with 45x plus 120 equals negative 12x minus 108. Before you move on, it's good to check each side separately. You could kind of cover. So if you covered the right side, and I looked at just 45x plus 120, can I combine anything there? The answer is no. 45 has an x in it and 120 doesn't. Therefore, they are not like terms. So that side is completely simplified. Well, then if I take a look at my right side, there is nothing there that I can group together, okay? This negative 12x has an x and the 108 does not. Therefore, I am done. That leads me to step 3. I'm going to bring my variables all to one side. So that means I'm going to take this negative 12x and bring it over here to the left side. To undo that negative, I'm going to add 12x to both sides. That leaves me with 57x plus 120 equals negative 108. If I look at this equation, I only have one term with a variable in it. Therefore, I'm done with step 3. I've brought them all to one side. Well, step 4 tells me to take my constants to that opposite side of my variable. So I'm going to subtract 120 from both sides. That leaves me with 57x equals negative 228. I've officially gotten my terms with variables on the left and my terms with just numbers on the right. So I'm done with step 4. Now, a lot of students often look at numbers like this that are very big and say, oh my gosh, I did something wrong, or those two numbers don't divide by each other. Before you make that assumption, go to step 5. Let's get this variable by itself. I know I'm going to have to divide by 57 because there's multiplication happening here. And I know I'm going to do it on both sides. So what happens is I get x left on my left, and I actually get negative 4. So I've gotten my variable by itself, and I found that the value of x is negative 4. If you plug this back into the original equation, I can guarantee you that it will work out. So that takes us to the end of equations. Should you have any questions, feel free to post a comment below or send me a message.